Hello and welcome to Saturday's edition of Cracking the Cryptic. And today we have got a puzzle for you by the brilliant constructor from Germany, Christoph Seeliger, one of my favourite constructors, a hugely popular setter on the channel as well. All of the videos featuring Christoph puzzles are always incredibly well viewed. And this puzzle is quite interesting because it's 3 stars out of 5 for difficulty. So if you're yet to get your teeth into a variant Sudoku, today might be the day to give the puzzle a try. What's it called, this puzzle? Oh, it's called Killer Hidden Arrows. And I'll read the rules in just a second. I've got three quick things to mention first. Well, the first piece of news is really rather mad. I was asked to play a small part in an audio comedy recently. It's called The Night Crew. It was written by Peter C. Hayward, who's a puzzle constructor, and I'm sure if you've been following the channel you'll be very familiar with Peter's work. Peter has written The Night Crew, and he managed to procure the services of some incredible voice actors and me. I play the ship's computer, so you can imagine how that might go. Anyway, if you're interested in listening to it, and I definitely recommend it, we'll put a link under this video, and it's got proper people in it. People like Prosody, if you know them, you will know of whom I speak, and just incredibly talented voice actors. What else? If you own Thermo Sudoku, our app, make sure you update it. There are 20 new puzzles there. We've tried to make them a range of difficulty, so there should be something for everybody. And yeah, that should be make for a few hours of fun at least, I would think. And also, if you're a patron of the channel, do check out DiMono's sequel to Everything Is Wrogn. That is right there. They're ready and waiting. It's already been getting some great comments, so yeah, do check it out. Now, what are the rules of Christoph's puzzle? I will read them to you. Apparently, I have done a puzzle with this rule set before by Scott Strossal, but I have no memory of that. I have no memory of this place, and so yeah, this will be new to me because my brain tends to forget things very quickly. Now, normal Sudoku rules apply. In cages, digits must sum to the small clue in the top left corner of the cage, and digits cannot repeat within a cage. So far, completely standard Sudoku and killer Sudoku rules. Now it gets interesting. In addition, each cage contains a standard arrow clue which is hidden. In an arrow clue, as many of you know, cells along the arrow must sum to the digit in the circle from which the arrow emerges. The circle part of the arrow will be at one end of the cage, with the arrow extending along the cage all the way to the other end. The circle may be any number of digits, and multi-digit totals are read in the direction of the arrow. So this is where it gets complicated. So we have to imagine that each of these cages contains a sort of standard Sudoku arrow clue. And that arrow clue could be a single digit circle, or, although maybe that is impossible in this puzzle. Well, I'll have to do, that's actually logic, I'll have to do when I come to the solve. I'm just looking at these cages and they all look rather large. So let's imagine we're looking at this cage and we're trying to think about how these rules will work. I think what we're saying is, and let's imagine it's a 2-digit total just for the sake of exposition. We're saying that 2-digit total is either going to be these two cells, and that could be, I don't know, let's put some numbers in. Let's put, no, in fact that's probably going to be impossible, but let's just say we put 12 in there. Now if we put 12 in there, that means these 3 squares have to sum to 12. But at the same time, we've obviously got to be making sure that the whole cage sums to 17. So that's going to be pretty interesting. Now, what else? Now, I think what it's also saying is that this could work the other way around. So it's perfectly possible for the circle part, the sum that we're looking to generate, to start at the other end of the cage. Because if it started here, then the arrow would end right at this space here. I might try and put some graphics on the video after I've recorded it to show this. In which case, the 12 would go like that. And would look a bit like a 21, but it wouldn't be a 21, it would be a 12. So you can see this is going to confuse me. I've got no clue what I'm doing. Do have a go yourselves. The way to play is to click the link under the video Now I get to play. Let's get cracking. Now, firstly, can we just deal with whether or not any of these... Can any of these be a single digit total? The answer is actually no, isn't it? That's impossible. Because if we try and put a single digit circle in any of these cages, all of the cages have at least 5 cells in them. So let's pick this one as an example. Let's make that as big as we can, 9. And imagine it was the circle. That would be saying that these 4 squares have to sum up to 9. Well, that's clearly impossible because you can't repeat a digit in a cage. So in this puzzle, you can never have a 1-digit total. All of the totals must be 2 digits. All of the totals must be 2 digits. So I'm tempted to try and do some maths to work out... Oh, the computer fan's gone on, as you can see. I'm going to be on my laptop for some time, so you'll have to bear with me about this. Now, can we do maths to work out... What I'm wondering is... If these add up to 17... How can I adjust this total to reflect the fact that in the arrow clue, one of these digits in this cage is not going to count for whatever it is. It's going to count for 10 times that. Because we know that one of the... I mean, this is perhaps not the best cage to choose, but let's imagine that this was trying to sum to 24. Then obviously this cell here is only counting as 2 in the 17 total, but it's counting as 20 in the 24 total. Right, I see. So basically, if the digit if we're using a tens total in the arrow clue, then we have to increase the 17 by 9, because this will count for 10, but it already counted for 1 in the 17, so we increase it by 9, we get 26. Yeah, so this cage we can actually say straight away sums to 13 as a result of that, because we know, what we also know is that whatever the arrow clue is, in this case the circle of the arrow clue will be 13, we know that that 13 must also be the sum of the remaining digits in the cage. So we've got 13 here plus another 13. That is 26. But let's think of it in killer Sudoku terms instead. We've got 13 here plus 3 plus 1, which is 17. That's a nice way of doing it. Although it's going to get more complicated if I have to increase these digits to be higher, isn't it? If you go for if we thought this cage was capable, or the arrow clue in this cage was possibly a 20 number, then this number is counting as 2 in the 17 and 20 in the arrow clue. So we'd have to increase the arrow clue by 18. Yeah, and that's clearly never going to work. You can't make the moment in a 17k, the moment this was a 20 number, you're saying those 3 digits there would add up to 20 something. That's clearly going to break the 17 total. So we are looking for a sort of teenage total in the 17 cage. We know it's 13. We don't know that starts on that side, do we? Bobbins. So we know there's a 1 in one of those and a 3 in one of those. And I really haven't made much progress in the first 10 minutes of the video. So we've got... Then I've got to make 13 in 3 cells somehow without using 1 or 3. So 2, 4 and 5 is 11. So there isn't a great deal of flexibility there. You certainly would need to have a 2 in the cage. But probably what I should do is to go through all of these cages and work out work out, well, see at least if I can get the arrow total. So this one is a 34 cage. Well, what we can see straight away is that even if I try and make this as small as possible, in the 30s, 31 for example, that's saying those 4 squares add to 31. Well, 31 plus 4 is 35, so this does not begin with a 3. Now, I don't think it's going to begin with a teenage number either. Let's make a teenage number as big as we can. 19. So this would be 19 plus 10. You can see that's not enough. So we know it begins with a 2, which means we adjust the cage total value by 18. We get 52. We halve 52 to get 26, and we now know there's a 2 in one of those squares and a 6 in one of these squares. That's lovely. Now this one, on the other hand, actually, yeah, 24 works the same way as 34. You can... Oh, no, it doesn't. Sorry, because I got an extra degree of freedom. I was about to say it can't begin with a 2, because 21 wouldn't work, but it works. Because 21 in those 3 squares, plus 1 plus 2 is 24. Ah! Okay. Yeah, actually, there's some sort of parity thing going on here. Because the moment you see a 20s clue, well, it's not really a 20s clue. The moment you see that when you add 9, if you add 9 to this number, the 24 number, you get 33, which you can't halve into an integer. So that you can immediately conclude, actually, if you think about it that way, that this cannot contain a 10s clue, a teenage clue. So it must actually be 21. That's the only way it can work. Now, this is really interesting. 21. And again, some of you may be seeing this stuff instantly, but I don't really apologise for having to think it through, even if I'm thinking it through for a second time. So 23 here, this will be a teenage number, because if I increase this by 18, which would imply it was something like, I don't know, 21. Let's guess. If I increase this by 18, I obviously get an odd number, which I can't halve. So I need to increase this only by 9, which means it's going up to 32, which means this is a 16 cage. So we want a 1 in one of those, a 6 in one of these. Now, are any of these pointing at each other yet, or do I just continue on my merry way? Yes, this one is. That square cannot be a 2, because if it's a 2, you can't put a 2 in either of those squares. So actually this cage, we now know how it's organised. This is a 21 starting here. These 3 squares add to 21. And probably what I should do, and you know I like to do this, is to colour in the total. So this is a 21 total. Let's carry on. 23, I need to add an odd number to that. So this is going to be a teenage number. Add 9 to it, we get 32. So this is 16. We know that there's a 1 at one end of it and a 6 at the other end. 32, I need to increase that by 18 to get 50. So this one's 25. Let's do those two. This 2 is now beautiful because it's ruling out 25 happening at the bottom of the cage. We get the 2 and the 5. Don't know if we get anything else. We can plonk a 2 in one of those squares by Sudoku. The 23 clue is a teenage clue because we need to add 9 to it to get 32. This is a 16 again, same as its friend there, look. So the 1s have got to go into one of those squares, the 6 is into one of those squares. Surely, can I rule one of these out? feel like I can, I just can't see how to do it. Sorry. Let's try this one. 24. So I'm going to need to increase this by 18 to get 42, 21. It's the same as that one, isn't it? So 2 goes into one of those squares, 1 goes into one of these squares. 2 is definitely in this column now, in the 24 cage. 2 can't go there because it must appear in one of the very sidemost cells of the 34 cage. This is lovely. Right, let us look at where 2 goes in box 1. Because we know from the 2's in the 24 cage, the 2 is not appearing in those cells. From this square, it's not appearing in these squares. From this, it can't be here, because we know there's a 2 in one side or the other. Now, could there be a 2 in either of those squares? No, because if you put a 2 in either of those squares, you're ruling 2 out of both those positions in the 34 cage. So actually, we can say there's only one position for a 2 in box 1, and it's here, which gives us 26. The 6 is ruling out a 6 from this square, which is lovely, so that means this must be the 16. That's doing damage to the way the 21 can work in the 24 clue, which now must start at the base of the grid and work upwards. This can't be the 13 clue now, that must come this way round. This can't start. This is a 16 clue and it can't start here. Whoopsie, because of the 1. So we can get rid of the 1, get rid of the 6, place the 1 and the 6 in this clue, get rid of the 1 and the 6. I think we've actually just got, haven't we, all the totals just done in a jiffy. And that means I can purple them all and make a pretty pattern. Let us look at the pretty pattern. And now, is it true to say we are now just doing killer Sudoku? I think it is, isn't it? So now we've reduced our killer hidden arrow puzzle to a killer Sudoku puzzle. Right, now let's do this. So now I can do 1s into those 2 squares. Whoopsie. It's harder to do killer Sudoku if you put the wrong digits in. 1 in box 9 is forced to be there. 1 in box 8 is in one of those squares. 34, 20. Right, okay, we can't put a 1 here because we know those 4 squares sum to 26. This is very strange the way I'm doing this, actually. Because having said that it's a killer Sudoku problem, I should really be looking at the 34. But actually what I did to do to get this 1 is I looked at those 4 squares and realised that they can't add to 26 if this is a 1, because I can't make 3 squares in the same cage add up to 25. That's impossible. So actually we get both 1s there. And I'm sort of still stuck in hidden killer arrow land. Have I done all the 1s? Yes, I've done all the 1s. Okay. Okay. So, where do we look next? We can place 6 by Sudoku there. And 3. These squares have got to add up to 21 without using 1 or 2. But 3, 4, 5 and 6 is 18, so there's still some latitude there, I think. 6 is definitely in one of those 2 squares. 25 there, and I've got a 1 in the total. So the other 3 squares add to 24. They are 7, 8 and 9. Now 3, look, is forced into one of 2 places in box 6. Okay, that doesn't seem to have immediately cracked the puzzle. 6s maybe? Yes, I think there is something going on with 6s. Let's do 6s carefully with Sudoku power. 6s can't be in those squares. 6s are in one of these two positions. Now, where does the 6 go in box 2? It's not in those squares, it's not in those squares, it's not in that square, and it's not in that square. So it is in the 24 cage. This is 21. Right, these two squares have to add up to 15. Because we know that the three of them together add to 21. Lop 6 off, we get 15. You can't use 6 and 9 because you'll repeat the 6, so that is a 7-8 pair. Okay, that's not actually cracked the puzzle, has it? My sense is we must need a 2 in these three squares. Is that true? Adding up to 13, if there was no 2, yes, there would have to be a minimum of 4, 5 and 6, which adds up to 15, not 13. So there is definitely a 2 in one of those cells. What are the other digits we've got at our disposal? We've got 4, 5, we haven't got 6 actually. 4, 5. So we can go 2, 4, 7 or nothing. Because if we drop the 4 out of it, we can't pair the 5 up with 6. And that's going to, anything else takes us too high. So 2, 4 and 7 go in. That's not 7 anymore. Okay. Can we go further than that? I'm sure we can. It's just whether I can do it with any sort of aplomb. Now, where next? 6. Yeah, 6 is yes. 6 is restricted in box 9 to one of 2 places. That gives us the 6 in box 3. Seven. What's this? 16. Can I get something done there? So, I can see that I can't use 1 and 2 in this total. These 3 squares sum to 16. I can't use 1 and 2. I think I can use 3, which is a bit annoying. If it was 3, you'd have to put it here. This would have to be 3, 4 and 9, because it couldn't be 5, 8 or 6, 7. Is there any reason that can't be 4 and 9? Nothing I can immediately see. If there was no 3... Oh, I think this is getting a bit bifurcated. I don't like sort of keeping on trawling through loads and loads of options. 16. Maybe this column? Ah, yeah, 3 and 4 haven't been placed. Let's have a look at that, see if we can do those. We can't. Okay. 26 into these squares. Do we know anything about that? 26. I can't use 6 in the total. I can't use 2 in the total. So I can't go 2, 7, 8, 9. That's not going to work. I can't use 3 in the total because that will be 3, 6, 8, 9. That will repeat the 6. So if I use 4, then I've got to go 4, 5, 8, 9. And that's all it can be. That is all it can be. There's not enough license, is it, to have anything else? If I go up to 5, and I'm looking for a higher digit, I've got to make 21 without repeating a 5 and a 6. Impossible. That's impossible. Well, unless I use a lower digit, of course, which is the point of trying the 4 first. So this is 4, 5, 8, 9. which is remarkably unhelpful. I don't believe it. Gosh, it really is it gets us a 3 in box 2. You can place 3 here. 3 goes into one of 2 places in box 8. And there must be a 2. There must be a 2 in one of those cells. So we get the 2 as well. So maybe all is not lost. That can't be 2. Three has to be in one of those. 3 has to be in exactly one of those 2. So 3. No, it's still resisting, isn't it? There's now no 3 in the 23 cage. So these are adding up to 16. There's no. Yeah, there we go. There's no 1, 2, or 3 in that total. Now 4, 5 and 6 adds to 15, so that's not going to work. This is 4, 5 and 7 as the only option, and the 5 here tells us where the 5 goes. Wow, this is tricky. So that's a 4, 7 pair. This square is now at 2. My fan is applauding me as a result of that logic. We can get rid of the 5 there now. 5 is in one of these 2 squares, so it's not there. So there's a 5 in one of these 2 squares. Aha! Yeah, and this 5 is ruling 5 out of that one. So in fact we know where the 5 must go in this funny 34 come 26 cage. So now what do we know? Anything extra? 4, 7 here. So these 2 squares are an 8, 9 pair. 8, 9 pair in box 6 gives us a 7 there. So these squares are now known in the sense that they are a 3, 4 pair, and we've got a 4 here in the 4, 7 pair. So that we can get the 4, we can get the 3. Three is now in this cage down here. Let's look at that. So we've got a 3 in the 24 cage and a 6 in the 24 cage. And what do we need? We need 21. So those 2 squares together will add up to 9. We need 12 in the rest of the box. We can't use 3, 9. So we're looking at 4, 8 or 5, 7. And would be a 4, 6 here. 3, 8 would be one possibility. That might work. 5, 7 looks less restricted. I think that just got one of those hunches that I'm missing a really obvious point about that, but I can't immediately see how to do it. So let's keep going with other stuff. 2, look, has to be in one of those 2 squares. This square? Oh no, I think 4, 7, 8 or 9. It's probably not where we should be looking. This row, you can see, if we look carefully, we've basically got the positions of those 6 digits. So we're looking to place 5, 8 and 9 in the rest. Where does 5 go in the row? This 5 here places the 5. This square is a lovely, that's an 8 or a 9. That gets us something here. A 3, 5 pair. And once we get a 3, 5 pair here, we get the 5, we get the 3. We can remove the 3 from that square. We now know this cage. 14. It needs 7 more. There's a 6, 7 pair at the bottom of the column. That 6, 7 pair does nothing. These squares are 2, 8 and 9 in some order. We can get rid of the 2 from that one. Okay. I shouldn't expect a Christoph Seeliger puzzle to just roll over and let me tickle its tummy. It's not going to do that. So 4, 7, 8, and 9 in this column. Can't see how to resolve that. Which gauges do I need to work on here? It must either be this one or that one. 16 here. I don't know if it's got a 2 in it. If it had a 2 in it, it would be lovely, because it would have to be 2, 5, and 9. And this square would be a 9. $16 cage. 2, 3. Apologies if I'm missing something obvious. I am not trying to, I assure you. 4, 8, 9. There's definitely a 7 in one of those two squares. There's a 7 in one of these two squares. There's a 5 in one of those 3 squares. That can't be where I'm meant to look, surely. 16. 2, 3, 4. 6, 7. Wow, okay. I'm very stuck. What else can we see here that's going to get us unstuck? We need to have a look at... I'm really not even sure where I need to look. I might have to just grind away at the W pentomino and the L pentomino at the bottom of the grid, I think. 16. 2, 4, 7, 8, and 9. These seem to just have an awful lot of options to me. Is there some way I can reduce things, or just get a little bit more? 4 in this row? No. Oh, that's nice. Right, this square is important. That square cannot be an 8, because it sees all 3 of those squares in the 26 cage, or 26 arrow, I should say, the 34 cage. That gets us a 7. That's an 8. Okay, I didn't do a great deal. Now we've got... Aha, the 8 does do work. It gets us a 9 and an 8 here. That gets us an 8 and a 9 over here. Now, we now know there must be an 8 in one of those two squares. There's no 8 there anymore. This square can't be 8. Okay. Yes, this 8 here. Where does 8 go in box 1? It's only got one position it can go in. That places 8 there. Now there must be a 7 in these squares. In fact, that square has to be a 4 or a 7 by Sudoku. And there's a 7 in one of these 3 squares. 8. That's not... where does the 8 go in that? In the 26 arrow, it's got to go here. 4, 9, 8. Still need to place 4, 7, and 9 in this, so... Not sure if we can do a little bit of tidying up. And we can take another stair. Have we got... Has that really made a difference? That square's not 7, because there's a 7 down here. So in this column now, we need 3, 4, and 9. So let's see if that helps us. No, I don't think it does. This column, we need 2, 4, 8, and 9. That can't be 2. This 8 gives us a 9 down here, using the power of just elementary Sudoku. I should have seen that immediately and didn't. No, that's still not enough though. 7, 2, 3, 4, 8, 9. That squares 5, 6 or 7. Sees 9 here, sees 8 there, as well as the 1, 2, 3, 4 in the column. Oh, come on. What is it we're missing here? 3. These two squares maybe. That one, not sure what this can be. It can be 4, 5. It can't be 6, 7 or 9, I think. This one can be 4, 5, 7 or 8. Oh, I'm sorry about this. I'm getting very badly stuck. This is a 16 arrow, so I need 7 more. If this is a 9, that looks like it's got very many ways. If I knew there was a 2 in here, that would really help. I'd get rid of this square being a 2. No. 16 here. Ah, you can't put 4 into that square. Because if you do, these two have to add up to 12, and they'd have to be 4, 8. Which they can't be, because that would repeat the 4. We can get rid of 4 from here. 5 needs 11. Ah, that can be 2, 9. Only 2, 9 though, actually. If that's 5, you can only do that with 2, 9. If that's 7, you need these to add up to 9. No, you can't make those add up to 9. Can you? I don't think you can. Now 9 means these have to add up to 7. That's impossible. Good grief. Right, so this is the cage we needed to focus on. That was not clear to me. That square can only be a 5. Which means this has to add, these two have to add up to 11. So they can only be a 2, 9 pair. Which means these two squares must be a 4, 8 pair to complete the column. That square now is restricted to being just a 7. That gets us a 7 and a 6. That gets us a 6 here if we trust the pencil marks. And why would we not do that? 7 must be in one of 2 places. This is a 2, 9 pair, which gets us an 8. The 7 gets us the 4 and the 7. That gets us the 4 and the 9. That square is a 3. 9 just by Sudoku must go here. This square is a 7. This square is a 9. The 7 is now there by Sudoku. This is a 3, 4, 5 triple. This square must be a 5. It sees 3, 4 in the column already. And now look, if we look down column 8, we just need an 8 to finish it off. Let's put the 8 in. That gets us a 4, an 8 here. This 16 cage now needs 2 cells to sum to 8 that are not 1, 7 or 2, 6. So this is 3, 5, which means the 2 can only go there now. That gets us the 9 and the 2 figured out. It's just so clever, isn't it? It just is so clever. Now those are 2 and 3, which we can do. Let's delete those. They were 3 and 5, weren't they? Can we do that yet? No. Okay. 3, 5. Get the 3 and the 4 at the top. Get the 4 at the bottom. Get the 4 by Sudoku here. Get the 4 and the 7. 7 goes here. This square is a 3 or a 4, which it sees 4 in the row. So it's a 3. That's a 4. That should be a 3. That 3 and the 5 go in. We still need a 5 here. And I think we're there. A flurry of activity brings us to a finish. So that is seriously clever. Let's click tick. Yes. Wonderful. Absolutely wonderful. I thought that was pretty hard, I have to say. 3 stars out of 5. I mean, it's a classic Logic Masters Germany rating because the people who are solving the puzzles there tend to be extremely fine solvers. So they probably flew through that relatively quickly. But I think if you had to work out the logic on the hidden arrows, you know, that bit of it was very nice, but not that straightforward. And then the killer Sudoku after that, again, it's not monstrous, but it does take some thought, and that's what we like. So, hope you enjoyed it. Let me know in the comments, and we'll be back later with another edition of Cracking the Cryptic.